Welcome everyone. Hopefully you can hear me. Hopefully you can see me. Sing out on the chat line if neither of those things is true. I'll have a quick look. Seems to be okay. Welcome to the last office hours of the year for me. It's been a long year for everyone, I'd imagine. And I'd imagine just as we thought, 2022 is going to be the magical new beginnings, another Greek letter of the alphabet wanders into play and it's all happening again. But hopefully we'll be able to get past that. Thank you for joining me this late in the year. I know at this time of year, often people have taken their breaks, taking holidays, or just are well and truly over anything that has to do with Zoom, Teams, GoToWebinar, etc., etc., etc. So I appreciate you giving up your time. Let me share my screen. I have a few slides. I have not many slides, which I'll explain why shortly. Let's share my screen and see how we go. As I always say, getting in touch with me is easy. Even over the Christmas period, I still like talking technology. That's probably an indication of what a sad life I have. You can get me on Twitter, but also if you just scan the QR code or go to linktree/Connor, you can get email, blog, Facebook, Instagram, podcast, etc., etc., etc. As I always say, for anyone that's new to my office hours, do not adjust your set. The slide content is generally down toward the left, such that when we turn this into a YouTube video, it will be my ugly mug at the top right, and it'll look hopefully a little bit more balanced. Bits and pieces, just a little bit of a backtrack as to what's been happening over the last month. Shout out to Francisco, who did a fantastic, literally I think a 14-day or even longer set of webinars for the Groundbreakers tour through APAC. Pretty much ran that whole show himself, so did a fantastic job, and thanks to all the speakers that contributed. I was involved in Database World, obviously no open world this year because of all the travel restrictions and the like, so we ran a thing called Database World. Hopefully you saw it. If not, the cool thing is we recorded every single session and made them all available on demand, including all the hands-on labs, so you can go grab those hands-on labs and walk through them at your leisure. Just search for Database World Oracle and you get to the link to the on-demand sessions. The December one was in APAC, so hopefully if you live in this kind of time zone, you saw them. But yeah, all available on demand. I think if you just go to that URL and add the word on-demand, you get to the on-demand replays. So they're all there and you can watch them. This is what I've done probably the last couple of weeks. Did 3 or 4, can't remember now, talks at Sangam. All India Oracle Users Group, probably one of the largest user groups in the world. Once again, a shout out to Sai and his team, fantastic event. And one of the things I thought was really cool was every session in Sangam was given live. There were no pre-recorded sessions. So big thank you to all the speakers who don't live in the Indian time zone, in particular, my colleagues from US Oracle who had to stay up incredibly late hours to do their talks. I did a talk with 2 people in Oracle, Sandesh, you probably know, Sandesh Rao and Marcus from the Rack team. And yeah, they were actually at a work Christmas party and went and sat in a room somewhere with a laptop and actually gave their talk. Little self-promotion, podcast. I've launched the podcast this year and hopefully you're listening to that. But really just want to get on to probably the final message for the year, which is I'd love for us to get back together as a community again. So please follow your local laws, follow your local guidelines. Let's get ourselves vaccinated. I'm dying for communities to be back in the rightful place they belong, namely at the right places. In person, I should say. And one thing I will say, I was having a look at the conference talks I've given this year. This is actually my 42nd presentation this year. This is the answer to life, the universe and everything, number 42. Out of those 42, 36 were outside normal business hours, which is one of the reasons I would like to do some face-to-face events again next year so I can get my body clock back into normal. So please, everyone, let's get vaccinated. So that's a picture of a cold turkey. And I'm going cold turkey tonight. And what I mean by cold turkey is no slides or very minimal slides compared to what I would normally do. I would love to say this is by choice, but unfortunately it's not. A couple of days ago, I broke my finger. And since then, it's been relatively difficult to type. And so all I've got in terms of slides is the questions that had come in. And so normally I present the text of the question and then I have some slides explaining the answer and some demos and stuff like that. So unfortunately, you need to bear with me tonight. All I have is the questions, and I'm just going to go off the cuff and sort of speak to camera and hopefully answer them that way without the benefit of demos, etc. Feel free if you want to call out and say, look, I don't trust you because you're just making stuff up. There's no proof in the demos, but it's the best I can do under the circumstances. But my apologies for that. But I thought I'd open up to you guys. The reason I got motivated to not just cancel the office hours and continue on was one of my talks at Sangam this year was a ask me anything you like. And to be honest, as a speaker, these are fairly daunting sessions because you're worried that you'll start the session and there'll be no questions. And then you sit there for an hour going, well, isn't this fun? And a credit to the Indian Oracle user community, literally by the time I'd started answering the first question that came in, I had like 30 questions in the queue, which I didn't even get to like probably a third of them. So they were just banging questions out there. So what I did was I asked Sai, I said, for all the questions I didn't answer, send me the list of the questions. He sent me all the questions. I wasn't entirely sure which one I answered or not, but what I did was I did my best attempt at getting all the ones I didn't answer, and I've cut and pasted them into tonight's session. But I want to make this nice and interactive. I'm going to offer you the chance. This is what I call my turn, your turn. So I will start with one of the questions that I did not get to answer at Sangam. But if you like, if you put your own questions in the Q&A, then I'll simply toggle back and forth between them. So I'm trying to be fair to the people at Sangam that missed out on me giving a question that they'd so generously asked. But also if you have your own questions, you can throw them in the Q&A and we'll simply toggle back and forth between them and we'll see how we go. So that's the plan for tonight. As always, you can sing out in the chat as well if you have any extra comments. But if you have questions that you want to ask, throw them in the Q&A and I'll regularly look from time to time and we'll see how we go. So with that in mind, let's just charge on and see what our good friends from the Indian community at Sangam asked in terms of questions. I literally, don't blame me for any formatting errors or spelling mistakes. These are literally cut and pasted straight out of the spreadsheet that was sent to me. So let's get going. I have a session connected in dedicated mode. When I fire the query select star from EMP, where does all the data go in order to give it back to me, the client application? And what about select star from EMP order by 1? Now, that's an interesting question in the sense that the second follow-up, the order by 1, seems to suggest that this person asking the question already has a bit of an inkling as to what's probably going on, but I'll jump back to the first part and let's clarify a few things. One of the things, the common myths that is held by Oracle is that when you run a query, we go get all the data and clump it somewhere. We sort of get your results and we store them somewhere and then we feed them to your client application. That really wouldn't be practical for any kind of large table because if you had a billion row table, it would literally take forever to copy those billion rows to somewhere and then send them through to you as a client application. When you do select star from EMP, we did this, I think, in a office hours session a long time ago. We go read a thing called the segment header, which is a way of the database telling us where the table starts. That gives us information as to where the extents are, and then we go read those extents and read the blocks for the employee table and extract the rows of interest. With a select star from EMP, that's all we have to do. We literally start with the first few blocks and they'll be loaded into the buffer cache if it's not a direct path read. Let's assume they come into memory or maybe already in memory. We'll simply read them into the buffer cache, extract the rows we want, and start sending them to the client application as it's requesting making fetch calls. So at no point do we have to copy the data anywhere. We simply read it from disk or from memory and sent it down the line to the client application. That's why if you ever do a trace, you'll often see like wait events like SQLnet, more data from client or waiting on message from client. We're not going to do anything until you actually send a fetch through. And that cursor that we've opened will actually remain open while you continue to fetch. One of the things you'll see in something like, say, SQL Developer is when you query your table, you get the first, say, 200 rows back. That's just a single query. We keep that cursor open. We're talking the desktop version of SQL Developer here. So that cursor remains open, and when you hit page down, we go back and we continue fetching. You might be thinking, well, if maybe 10 minutes passes between the time the person gets the first 200 rows and then the second 200 rows when they press page down, etc., what if the data's changed? That's the beauty of Oracle's read consistency model. Every result you ever run is preordained. The moment you start fetching the first row, every single row in that result set will actually come back the same as at that point in time. And the way we do it, as we've spoken in other office hours sessions before, is we actually undo any changes that we encounter along the way. So we're simply reading all those blocks for the employee table, and then we undo changes that have happened after the query began, and then we farm those rows straight to the client application. It's a bit different when you do select star order by some column, because we do need to sort the results. And in those situations, we do indeed have to store the results somewhere, because the result no longer is the same as the source data. We're actually getting some data out and rearranging it. In this case, sorting it, what's order by one? Sorting it by order of employee number. It is possible that the database may satisfy that query without doing a sort. Order by one, it may so happen that the database decides that I could read the table in order of, say, an index on that column, and then the same rule as what we just spoke about applies. We simply walk through the index, walk through the blocks, and farm those rows out. But assuming we have to sort the results to get the result, that sorted result will actually go into your client PGA. If it's a small result set, it'll go into memory. So we actually do have a copy of the employee table, freshly sorted now, in that client's PGA. Obviously, for large tables, we're not going to be able to store all that information in memory, and therefore that result will be dumped out to the temporary table space. But in the same way that we farm rows to the client application only as they're requested, once we've dumped that sorted information out either to the PGA or to the temporary table space, it's only as the client issues fetch calls that we then go get that information and send it down the line. So hopefully that answers that question and you get an idea for how we're going to go slide free tonight. Oh, we got stuff in the Q&A, cool. Okay, so we have some corollaries here. What happens in the case of direct path 3? The table is huge in size and not going to memory. Very little difference actually. What happens now is I'm reading blocks directly from disk, but rather than going into the buffer cache and then coming back to your PGA, we are literally bypassing the buffer cache. We're simply grabbing them from disk directly into your PGA and then doing the same operations. There are some special examples that go on, like if you're doing things like parallel read, etc., then we do some checkpointing information. There's a few things that might need to go on because we also have to take consideration of the fact that you might direct read from disk, yet there may be a dirty copy of that buffer in memory. And so we have to do some checkpointing to make sure that what we're seeing is the actual correct moment in time. So there's a few idiosyncrasies that go on for direct path reads to make sure that we're not getting corrupt data, but the fundamental process of read a block into your PGA, give it to the client is unchanged. Type that one. Okay, so this is a genuine question. So we've covered one from Sangam. Let's jump on to now John's question. Lately, let me drag it over here so I don't look I'm looking too far left. Lately, we had one session doing online partition move, blocking another session doing inserts on historic tables. I was surprised, but it appeared to be direct load inserts. I think I know the problem, but could you confirm my suspicions? Okay, so I'm not sure if you mean, John, by you clarifying in terms of the your programs are doing direct load inserts or the online partition was doing direct mode inserts. I'm not entirely sure what you're asking there, but I'll probably best way is I'll explain my understanding of how the online partition operation works. In effect, what we're doing is creating a materialized view, for lack of a better term. We actually will take if you think about how DBMS redefinition works, what we do is if I'm converting this table to a partition table, the first thing we're doing is taking a direct read path copy of that large object into its new partitions. Before we initiate that operation, we create some journal tables. You'll see them, I think they're called R, they have an R prefix and I think an M prefix, but you'll see a few more objects appear in your schema. They're journaling tables to pick up operations while we do that large copy, and then we'll reapply those ones afterwards. What I don't think you'll be able to do is your own direct mode operations on the source table while that operation is going on. And one of the things that's probably a little bit sort of vague in the documentation, but it's sort of on various blog posts from the very large database teams, is one of the things we always strongly recommend is any kind of online operation, whether it's non-partitioned to partitioned, splitting a partition, dropping a partition, even just an online move of a heap table. We always recommend you do those in the quietest period possible, because there are some points of the exercise where we would need to have some moments of serialization simply to guarantee that you don't get a data corruption. I hope that sort of answers your question. I hope it's not too vague, but hopefully that understands where we go there. Okay, back to our slides. Exadata question. Can I still promote indexes to the Exadata database, or do I need to drop them? Will Exadata ignore indexes? And this is, I must concede, probably a misinterpretation that is somewhat of Oracle's making, because when Exadata came out, one of the things that we were very keen from a, let's call it a marketing perspective, is we were keen to say how incredibly impressive the storage infrastructure was and the amount of smarts that go into the storage algorithms. We have things like storage indexes, smart scan, hybrid columnar compression, online compression, all sorts of goodies sitting there, zone maps in the Exadata storage infrastructure, which make the ability to churn through large amounts of data incredibly efficient and fast. However, this is not to say that that means you don't need any more indexes. And I fully concede that one of the things that we would be sort of often saying is, you can do away with indexes in a sort of a hand-waving sort of broad gesture. And that's perhaps a little bit too much on the marketing hype and less on reality. Probably the easiest way of proving why indexes are still relevant on Exadata is on our cloud, the automatic indexing feature runs exclusively on Exadata machines. And obviously, we wouldn't have a facility that does automatic indexing of tables if indexes were not needed at all on Exadata. The reason we often need less indexes on an Exadata machine is, as I said, the speed of being able to do a full table scan is dramatically faster on Exadata. And ultimately what happens is we end up with a costing decision. In all databases, in fact, one of my podcast episodes, I said every index is a bug on your database, because the only reason we ever had indexes is because of the limitations of hardware. If every full table scan took a millisecond and every constraint check took a millisecond, you would never have indexes. Indexes simply solve a issue with hardware in the sense that you can't scan an infinite number of rows in a 0 point in time. But in that sense, the only reason we ever add indexes is to solve you could call it a issue with the database in terms of its performance. Why would we have a primary key index? To stop uniques, because it's too slow to check for uniqueness and therefore lock a whole table to scan the whole table. Why do we have indexes for foreign keys? Because it's too slow to scan a table in case you want to delete a parent row. Why do we have indexes just for performance? Because searching for a subset of rows can't be done in 0 time. So every index is simply effectively a workaround to the limitations of the physics of servers. All Exadata does is change that balance. It means that the benefit you obtain from an index has to be that much better, because the cost of doing a full table scan is that much lower. You can scan so many more rows before you move into that area where an index would actually be beneficial. So hopefully that clarifies that. Anyone that says an Exadata machine does not need any indexes is dreaming. There may be some Exadata machines out there that don't have indexes. You might have some large-scale data warehouses where I've seen data warehouses even not on Exadata, which have very few indexes or no indexes, because all the constraints are validated with queries and they're set to disabled rely, which means you've told the data that the constraints are valid, but you haven't actually implemented them with underlying indexes, etc. It's generally a risky thing to do. I'm a big fan of still having genuine constraints on a data warehouse, but generally what you'll see on warehouses, and even more so on Exadata, is dramatically less indexes, but there are always probably going to be some. Just my chat here. Would you think this is a forum to discuss the reasons behind Central Apex and BugDB? Okay, yep, this is an internal Oracle question. Okay, we will talk about that if we get a moment. But first I'll answer this one that's come from an anonymous attendee. Come on. We are EBS 2-node rack on Exadata and recently upgraded to 19.10. Are there any post-implementation steps that are needed for Exadata when going to 19C? One of the things I'll always recommend for any kind of upgrade is use auto upgrade. That gets better with every iteration that we put out on MyOracle support. And one of the things that auto upgrade does its best to do is take on that burden. It used to be as DBAs, we would sit there and look at the upgrade manual, and the little middle bit, which is about this big, would be the actual upgrade part. And there'd be 25 pages of preliminary steps and 25 pages of post-upgrade steps that you were meant to take care of. Auto upgrade tries to consolidate all that into the actual program itself. And so generally what you find is if you're using auto upgrade, it should take care of the vast majority of these things for you. But I always should say you should defer to the upgrade manual itself, because normally it has a particular set of sequences. And also always jump onto Moz and do some searching, because often there are particular platform or release update or version specific things that might be specific to you. For example, 1910, a classic one was, with all upgrades, we never touch compatible. We never do until we're guaranteed that the upgrade never will go backwards. But in all those cases, typically you'll set your compatible parameter to 19.0, just the base release. However, what you've seen now in some of the release updates for 19 is things like 19.8 lets you have SQL macros, 19.10 lets you have blockchain tables. So there may be some scope there now that you're on 19.10 to look at maybe modifying the compatible parameter to pick up some of those features that have only come out in later RUs. They're not Exadata specific, but you get the idea. There's always some niche scenarios where you might want to check either on Moz, either by raising an SR, or by checking the upgrade manual to see if there are any particular things that came along for your particular platform, particular RU number, which might be specific to your needs. Hopefully that helps. Okay, before I get to this question that's come in, I'll do one more on our set of slides for our Sangam attendees. Let's talk about ASH and AWR. ASH and AWR store snapshots which are captured at an interval of 10 seconds. Based on this, how do we identify sequels which are missed, that I'm assuming missed from being that capture because they're at 10-second intervals and probably cause performance issues? So a quick recap. Active session history grabs the details of every active session on your database once every second, and it stores that in a circular buffer in memory. Because memory is not infinite, at regular intervals, we dump that information down to the historical tables in AWR tables, and we collect them via snapshots, etc. But to keep things manageable in size, we do a sampling algorithm. So out of those 1 second snapshots, we grab every 10th one, and they're the things that are stored historically. The logic here is pretty simple. On an actively running system, let's say your ASH data might be held for say 12 hours. The idea is if you have a problem, you can go back and look at that granular 1 second intervals to see maybe where the problems were. If you had a SQL statement that ran for say 25 seconds, you would see 25 rows in the ASH data once every second, and you could use that information generally by counting the rows to see which sequels were perhaps problematic. As that data gets aged out, that same 25-second SQL would now appear simply twice or maybe 3 times in the historical information. Because they are 10 seconds apart, you could probably still make some inferences about the slow runningness of that SQL. A couple of key things I would recommend to look at here is in your ASH data and your historical ASH data, you'll often see the SQL ID column. And obviously that's the SQL ID is how we tap into things like VDOLA, SQL, etc. However, another really important column on ASH and AWR is a thing called the SQL exec ID, which is like a sequence number for each time we execute that SQL. So in your ASH data, if you see a SQL ID of ABC and a SQL exec ID of some 1, 2, 3, and that stays constant for 25 rows, that's a single execution that ran for 25 seconds. If you see the same SQL ID, but the exec ID changes once for every one of those 25 rows, it means that you actually had 25 executions of that SQL that were picked up. You may have had a whole lot more because, as we said, ASH only grabs things every second. You may have run 20 times a second or 30 times a second, and just one particular one got grabbed at that active point in time. So what I do is I use the ASH data as well as a combination of the other things like $SQL stats, because $SQL stat will store things like execution counts. If you've got a long running slow SQL, Ash and AWR, it stands out like a sore thumb or a sore finger. If you've got a system that's busy or systems that are having problems because you've got a small, fast SQL that's being run many, many, many times, then the execution counts in $SQL stats and DBA HIST SQL stat will pick those out as well. One thing I will say to Ash, and this is, you can, if you search for Ash on my blog, connor-mcdonald.com, one of the things I used to do when I worked at customers was I was always a little bit sort of pessimistic about the fact that we threw away the Ash data so quickly, 9 out of every 10 samples. And there are two ways of actually avoiding that. One is there is actually an undocumented hidden parameter, starts with an underscore, which tells you how many samples we're going to keep. I think it's set to 10, which means it's every 10th sample. If you set that to 1, you actually keep everything from your Ash memory into your historical data. That obviously builds up faster. You use a lot more space, but it can be done. One of the things I used to do to get a bit more control over that was, rather than tweak that parameter, I would leave my standard AWR tables as every 10th sample. But I had a routine which simply copied the entire Ash structure out to my own partition table, called it, Ash history. And all I would do is every hour, I'd simply dump everything I hadn't got already from VDOLA active session history into that and just let it grow. I could compress that. I could remove the columns that weren't of interest to me, but I could keep every single row for, say, a month or so. The reason I found that useful is, depending on the customer, but it was all those things where someone would come up and say, hey, last month's batch processing ran really slow. Do you know why? And obviously, having that low-level Ash data for, say, a month or even 3 months was really useful for going back for those longer-term queries. And as a result, you model it based on the customer. If the customer has, say, a weekly cycle of critical, say, reports or batch processes, you'd only keep 10 days. If they have things where, like, every 6 months they run some critically important stuff, you might choose to not keep all 6 months, but you might keep the period in and around those 6-month intervals. So you can always do compare and contrast. So on my blog, there's a routine which is simply keep a copy of Ash, and you can keep it as long as you want, and it does automatically partition maintenance, etc. Or you can tweak that underscore parameter with the guidance and approval of Oracle support, obviously, to actually collect more granular data in your historical tables. So that's some ideas on how you can get more granular Ash data for performance diagnosis. Okay, here's a question that is relevant both inside an Oracle, but also probably affects customers outside, so it's worth a quick discussion. One of the things we have inside Oracle, unsurprisingly, is a lot of databases. And historically, the way we've communicated between those databases is with database links. It's generally the de facto mechanism of doing that level of communication. However, in these worlds of clouds, where what databases used to sit in the same data center now may sit in different regions, different continents, have different hardware, different versions, etc., the management of database links can be somewhat problematic. In particular, you've got to set up secure SSL communication, have wallets, etc. It gets more complicated. One of the things that we're doing inside the Oracle organization is we're generally moving away from database links and moving to REST calls to do communication between databases. And the question is that a good thing or a bad thing? For me, I don't see the two as mutually exclusive. Inside Oracle, I think we're pretty much almost exclusively going to REST, but my own personal opinion is I don't see the two as mutually exclusive, and I can give you a couple of good examples here. If you've used AskTom to get into office hours, there's a close relationship between AskTom and its partner application, the DevGym. And DevGym has the quizzes and workouts. The administrative facilities for office hours sits in DevGym. The publishing of office hours information comes out of AskTom. There's a lot of cross-pollination there. Those two applications sit pretty much in the same database. They're just separate schemas in the same database. And what we do is we use effectively database links because those applications didn't used to sit in the same database. So even though they're actually in the same database, just two different schemas, because historically they were in two different databases, we still use database links to talk between them. But we know that it's a very, they're almost pairs. They're almost brother and sister, those applications. They'll never really go anywhere one without the other. There are other applications inside Oracle where that link is far more tenuous, where the application needs occasional reach out to other parts of the organization, and those other facilities are much, much more tightly controlled, etc. In those scenarios, I think REST is actually a good idea because REST effectively breaks that close coupling. In particular, the moment you suffer with a database link, you're into two-phase commit kind of territory. And what you don't want is to have, for example, one mission-critical database being beholden to, say, outstanding transactions from some very non-mission critical database which launched a transaction via a database link. So I think there's a happy sort of hunting ground there for both people. I think REST is a good idea when you want to do non-transactional work between databases, but also for those databases where they do have a very close relationship and one probably wouldn't exist without the other anyway, then database links probably aren't going to cause you any headaches. So that's a question that's come from someone internal to Oracle, but I hope that explains the question for anyone doing that kind of activity outside the Oracle Corporation. Okay, this is an excellent question that's come up. Someone said, will container pluggable databases become mandatory in the future? The reason that's an excellent question is I do know that actually coincides with one of the questions that's coming, which we're going to cover shortly. I'm not sure where it is, so we may as well cover it now. Will pluggable databases become the only option in the Oracle database? There is a very simple answer to that, and the answer is yes. And when will it happen? It has already happened. 21C does not permit you to have a non-pluggable database architecture. As you upgrade, you must move to a pluggable database. Originally, it was going to be 20C, was going to be the one where we said, yep, that will not be a non-pluggable option. With all the dramas of COVID, we didn't want to, in 2020, we didn't want to be launching a new database onto people in the middle of the work crises that were happening at the time. People were losing their jobs, people were working from home, it was just chaos. The last thing people needed on their workplace was, oh, look, here's an upgrade to 20C for you. So we deferred 20C entirely and moved that into 21C. From 21C onwards, there is only pluggable databases. Now, before you get all upset, and in fact, funny enough, the question I had that came in my slides was not just a one-liner, it was much more, I can't believe you're doing this to us, why are you forcing us to do this, this is a nightmare, yada, yada, yada. But the reason it makes sense for both you and Oracle to move to a pluggable database architecture, let me talk about you first. Number one is pluggable databases have a much more dense feature set, because the things that used to be very complicated across databases, I want to copy data, oh, it's got to be data pump or database links, etc. I want to share information between databases, well, that's materialized views, etc. A lot of those things can be solved with a pluggable database architecture. We have things like application containers, which are a pluggable database that sits with common data across multiple pluggable children, so to speak. So there are a lot of facilities and features available in the pluggable database architecture that will help customers. Now, before you get stuck into me about, yes, but I only get that if I choose licensing, this is true for certain levels. You get 3 pluggables for free in all versions of Oracle. If you're running Express Edition for playing around, you get as many pluggables as you can fit in the storage areas. Putting the licensing thing aside, let's now talk about why pluggables helps you even if you never use any of the pluggable features. That sounds a bit more challenging proposition. At the moment, Oracle, we are maintaining 2 code bases. We have a data dictionary, which is non-pluggable, and a set of data dictionaries, which are for the pluggable architecture, because you can choose either or in all versions up to 19C. What does that mean? Let's be real here. Oracle is a software development organization. Let me try that again in English. Oracle is a software development organization, just like you probably are in. We have developers. We have a fixed number of developers, a fixed number of development cycles, a fixed number of resources. What that means is we currently have support staff, development staff working on 2 separate code bases, 2 sets of different kinds of bugs that might come in, 2 sets of features that need to be worked on, 2 sets of support operations that have to be conducted. Ultimately, what that does is spread the effort and resources more thinly throughout the organization on the code that is being delivered to you, the customer. What does that mean? Generally, the risk of bugs slipping through, the time taken to deliver enhancements is larger because we are simply spread more thinly. I think it's an excellent thing for both customers and Oracle once we get to 21C, because now we only have the pluggable database architecture. We still have the same number of developers, we still have the same number of support technicians, and now they get to focus all their energies on one architecture. That's obviously better for us, but it's better for you as well. You get less bugs in your products, you get more features faster, you get more rapid turnaround on support issues. So that's why we're doing it. We get a lot of feature benefits, but more importantly, even if you never adopt a multi-tenant license, you're going to get benefits just in terms of the quality of the product and more features more quickly. So hopefully that answers that question. I think it's a good thing. Maintaining 2 code bases, whatever kind of software you're building, if you're maintaining multiple code bases, ultimately it just means harder support and more risks of bugs. Okay, back to our slides. After creating an index, query response time and elapsed time is improved a lot. The query is running good, but causing very high CPU spikes now. What else should be done to reduce the CPU spikes? Or is it really needed to fix the CPU spikes? Just checking my chat here. Okay, let me start with something a bit controversial here. CPU spikes are a good thing. Let me justify that statement. What's happened here is, because we've used an index and probably assumingly we've now turned away from a full table scan for this particular query, a full table scan is most likely doing direct reads. It's reading from disk straight to the PGA to the client. What this means is you're probably not hurting the CPU greatly. Don't get me wrong, I/O still burns CPU. But what you're seeing there is your query performance is slowed because of the I/O infrastructure. That is the binding factor here, or the limiting factor. Now that we're using an index, generally the most common blocks you'll see in the buffer cache are index blocks, both branch blocks and leaf blocks, because so many applications tend to use common blocks, index blocks. What this means is a vast majority of this query's performance now, or results, are being served out of the buffer cache. Buffer cache are memory reads, and the surefire way to consume CPU on an Oracle database is to do buffer gets. It's probably the leading cause of CPU consumption. This is not a bad thing. CPU consumption is the aim in an Oracle database. Don't get me wrong, the idea always is to have optimal code first. You optimize first such that a query is using the least amount of resources. But once you've reached that sort of goal, then what you want to do is actually use as much CPU as possible, because that effectively is the amount of load you can accommodate. I'm always blown away. I worked for years at many places where there were metrics along the lines of, we want to keep our Oracle database at 60% CPU always, no more than 60% CPU, because of that paranoia about needing headroom. But let's be real here. What really is CPU for any customer, whether it's on premises or cloud? CPU is money. You get charged by the CPU when you have Oracle on premises. You get charged predominantly by the CPU when you have Oracle in cloud. If you're saying, I'm never going to go above 60% CPU, what you're really doing there is not paying 40% extra for resources you're not using. For me, the ideal server runs all the time hot, because that means you're using exactly the amount of money that you've paid for your Oracle facilities. The joy of having Oracle on cloud is that you can run really, really hot, and then when you do need that headroom, you can simply blip it up a bit and still run hot. But yeah, I'm a fan of use the CPU you have. Don't sit there and sort of, what do we say? Yeah, you can't bank it. You can't put away a surplus CPU and then call on it later. It doesn't work that way. You use it or you lose it. So I'm a big fan of running machines hot. Because of the things of hyperthreading and cores, you need to be a little bit careful here, because the definition of a CPU running hot might not necessarily be 100%. Often a CPU will be reporting through the various operating system facilities as, say, running at, say, 70%, when in reality it's actually maxed out because of the way of hyperthreading and cores work. But once you find that moment where you think, yep, workload slows down after this threshold, then yeah, your aim is always to run as close to that threshold safely as possible, because that means you're getting the maximum return on your investment. And ultimately, any kind of IT resources are about getting the best bang for your buck. So yeah, it's good that your CPUs are running hot. That's the objective here. That might be a bit controversial, but hopefully I've justified that stance. Oh, no questions from the crowd. We'll continue on. We're on 10G. Should we upgrade to 19C or 21C? You have to do both. Now, let me explain. If you're on 10G, I think we can safely say that you've been hesitant to do upgrades because 10G came out, I don't know, around the 2000 and when did 10G come out? Probably, I'd say 15 years ago at least. So if you're on 10G, there's obviously a very strong hesitation to doing upgrades. Otherwise, you'd be on at least some other version by now. And I would stress, you definitely want to be not on 10G, because the moment a product goes out of support, the thing that kills you is not the stability, because generally all the Oracle databases get very stable over time, is the fact that you don't get security patches. No security patches means you're in dire straits. As we've seen from the last few days with the Log4j stuff, you can get stuck in an awful mess if you have a security hole in your software products. That's the drama of staying on old unsupported database releases. You no longer get any security fixes coming along. So if you're on 10G, presumably you don't like doing upgrades. That means the natural choice for you is 19C. 19C is what we call a long-term support release. What that means is once you go to 19C, we will continue to support it and continue to release patches, in particular security patches, I think until 2027, might even be 2028. So if you're on 10G and you've obviously been there for a long, long time, you should jump to 19C because then you can stay there for a very long, long time as well. And that's the assumption I'm making there. However, the reason I say you must also go to 21C is for those people, and this doesn't matter where you're coming from, whether it's 10G, 11, 12, etc. For those people who upgrades are a pain, they don't like doing them, they're going to go to 19C because it's a long-term support release. Don't forget, another long-term support release will come at some stage, and it's going to be 23C and probably 27C or 26C, one of those things. At some stage, your 19C is going to run out and you have to go to the next long-term support release. What's going to be different in those long-term support releases? Let's say it's 26C is the next long-term support release after 23C, and you're going to hang on to 19C way up until 26C. 26C is going to contain the features that came in 21 and 23, and if there's a 24 or a 25, all the features and changes to the product that come in those releases will be in the next long-term support release. And if you go from 19 to 26, all of a sudden, during that upgrade cycle, you now have to adopt all these new features and new paradigms and new tech, methods that you've never seen before. It's far safer if you're obviously a low-risk customer. Your low risk is about doing less upgrades. Far safer to upgrade your production systems to 19C. At the same time, grab some sandboxes, some private databases, even developer, playthings, put them on 21C so you start to become familiar with them. And then when 23C comes out, start to become more familiar with them again. Because that way, when you do make that big leap to the next long-term support release, whether it's 23 or something even farther on, you know what to expect. Because ultimately, knowledge is the way you lower risk when it comes to doing upgrades. Classic example, I've had so many people reach out to me on Ask Tom, Twitter, email, etc., saying, I've installed 21C, I can't connect with my tnsnames.aura. And what they haven't realized is that 21C uses a different setup for the Oracle Home. The TNS names files are not under Oracle Home Network Admin. They're stored elsewhere because 21C uses the read-only Oracle Home. These are the kind of things that's really good to find out when you're just playing around on a non-production system. If you were doing an upgrade from, say, 19C to 23C, you would make that discovery probably a week before you upgraded after you install the software, and then you're going to be in a bit of a panic. So I stress, even if you are a customer that is solely motivated to go into between long-term support release to next long-term support release to the next one, etc., you should always be exploring, working with those intermediate innovation releases to pick up the new features, to pick up the new paradigms, the new methods, such that when you do go to that next long-term support release, you're well versed in what's going to happen. That makes it much lower risk for you and a much more successful chances of a good upgrade. Hopefully that makes sense. What are the pros and cons of purging an AQ table? I was told by support, oh, here we go. I'm going to get myself into trouble here. I was told by support that I need to purge my queue table, but there are 100,000 plus messages. And when I'm on the scripts and support, the script takes forever and starts causing issues at the DB level. Is there a way to purge all of them at once? If so, will it cause any issues? Okay, so what we've got here is we've got 100,000 messages that need to be purged, and support have given our attendee here a script that actually says, here's how you can purge a single message. And the way we have in the PL SQL routines to purge messages, you can specify a criteria. That purge condition, as specified here, is deleting a single message, which means if I need to delete 100,000 messages, I need to call that routine 100,000 times. That's going to take a long, long time. The purge condition on an AQ table effectively becomes a where clause. All it really does is when you run it, it becomes a where clause against the queue table. That means it doesn't have to refer to just a message ID. As long as you can come up with a particular criteria to remove those rows, you can do it in obviously a single or a small amount of passes. So as long as you can identify those messages you want to purge in an efficient mechanism, a purge shouldn't actually take too long because it is literally just a delete. The queue table is just an Oracle table with, I think, 2 indexes on it, maybe 3. So it takes about the same amount of time. For example, if you wanted to simply erase the entire table, you can do a purge condition of 1 equals 1. And that will simply do a single delete across the entire table. It'll delete 100,000 rows. If you have particular criteria, as long as it could be expressed in a where clause, then you can do it with a single delete. If you have more complicated criteria, you could pass in multiple purge conditions with multiple calls, but each one getting a batch of rows. So hopefully that helps. If you want to purge lots of rows from a queue table, the ideal is to get a where condition, which would do it in the least number of deletes possible. One thing I should say is it generally makes sense if you have messages you don't want in a queue table. The reason I'm generally a fan of purging them is because the queue table is navigated via an index, generally I think in descending order, and over time, if you put a massive amount of rows in there, those indexes can start to get a little bit stale because if you've got rows floating around in there, generally it means they got fragment, the index is full of little sparse holes. If it's all down one end, if it's all just old messages, you won't notice any problems. If it's lots of little sparse little holes, then what you have is leaf blocks scattered with poor utilization all throughout the indexes, and that can slow down your query performance when it comes to dequeuing messages. Okay, another one from the audience. How are we going for time? We're doing okay. Are index reorganizations considered a regular DB maintenance task, or they do need to be done in a targeted approach to fix specific performance issues? In other words, do we need to look for fragmented indexes, specifically B-tree indexes, at regular intervals across the board and rebuild them as a regular maintenance task? Let me give you my thoughts on rebuilding indexes. My default position is do nothing. And then I only say, do I need to act if I encounter some sort of problem? Because the whole objective of a B-tree index is literally to be a maintenance-free activity. Now, there's a lot of scenarios under which you might choose to or choose not to rebuild those indexes. And for example, if I'm doing data warehouse loads, generally I would, for example, mark an index unusable, do my load and rebuild it, because that's a way of speeding up the overall load process. So there's plenty of niche conditions why you would rebuild. But in terms of transactional activity, just the day-to-day transactions on a table, insert, update, delete, etc., B-tree indexes are designed to run just fine. You almost never have to do any rebuilding of them. Now, one thing I can recommend is if you do a Google search for Richard rebuilding the truth. There's an ex-Oracle guy who's now an independent consultant named Richard Foote. He wrote an excellent white paper many, many years ago, but it's still totally valid today, called Rebuilding Indexes, Rebuilding the Truth. It's a PDF file, and he walks through all the various scenarios under which people often think you need to rebuild, but generally don't. But one thing I would stress is if you choose a default position of, I'm not going to rebuild anything, and then only act if I see things go badly for particular objects, you're probably going to be fine. Good example is the Ask Tom database, which is not particularly large, I will happily admit. But the Ask Tom database is 21 years old. First question came in May 2000. In those 21 years, we have never rebuilt an index. Simple as that. It's very, very unlikely you ever need to rebuild B-tree indexes, except for specific niche conditions. And Richard's white paper is a great way of going through them and seeing which particular scenarios might be pertinent to you. With the arrival of autonomous database, do we still need to partition tables manually? In the autonomous marketing, it seemed to imply that its self-tuning index creation capabilities is sufficient for massive performance increases, but no mention is made of data or index partitioning. Okay, this is because autonomous is a journey, not a destination. Let me explain what I mean by that. The first iteration of autonomous database, the things that we made autonomous were generally patching, in particular looking for security issues, and what we call health checking. A lot of the facilities you might run manually on your system, things like cluster health check, trace file analyzer, autonomous health framework, all those things have been turned into automated solutions on our autonomous database. Now, for customers, they didn't see this and they're like, well, it just looks like another database to me. But ultimately, we added the autonomy first, probably where it mattered most, which is let's make sure that we're creating databases that are going to be robust, never go down, and we're going to detect problems before customers get exposed to them. The next line along that journey was, okay, how do we now more proactively make customer applications or databases run better? And the first thing there was automatic indexing. Now, to explain how automatic indexing works, I just want to spend 1 minute on this because it becomes pertinent to some other facilities which are coming soon. The overriding principle for automatic indexing is we can do no harm, because an autonomous database it's a bit like you don't send a guilty man to, you would rather let a guilty man go free than send an innocent man to prison. Autonomous works on the same principle. You would actually rather have things not running optimally at the risk of never making things run worse. And so automatic indexing adopts that policy, which means when we're looking to do automatic indexing, what we do is we might find some bad SQL. We'll create an index unusable first, which means it's an empty index, doesn't take up any space. Then we'll do an explain plan to see if the optimizer would maybe use it. Then if that passes, then we'll create that index, but it's invisible. And then we'll actually run that SQL. We'll actually take your SQL that's running slowly, and in the background, we'll have a job that runs that SQL literally to see if it's genuinely better. Just because the optimizer is going to use an index doesn't mean it's going to make an execution run better. It might make it run slower. So the optimizer has to think it's going to be better, but then we prove it will genuinely be better, and then we will let that index become active and visible. So it's always that policy of we're never going to make things worse. We have this no harm policy. We're always going to strive to make things better. The price of that ultra cautious facility is that we work harder, because we actually had to create that index fully, and then we had to run your SQL to make sure it was going to be better. And obviously at a larger scale, if you've got 100 SQLs that need to be performance improved, or we find 100 bad SQLs, we might create 10 indexes to serve those, and then we're going to run those 100 SQLs in the background to make sure that they all get better. That's how automatic indexing works. Now, that's just one path along the journey. What you do have now in autonomous, but once again it's set to off by default, is automatic partitioning. Why do we set it off by default? think about what we have to do if we're going to adopt that same ultra cautious attitude. Because I've got some demos on automatic partitioning, which I'm still, when I get a typing hand back, I'll do some blogging on them. But what automatic partitioning does is looks at your table, which say has 1 billion rows, and says, looking at the queries against that table, that's a good candidate for partitioning. But I can't just go, let's just partition it and see what happens, because that's not that ultra cautious approach. We will take your 1 billion row table, we will copy it to a partitioned 1 billion row table. Then we will take those queries that were running against your non-partitioned table and run them against this partitioned version and see if the queries get better. And if they do, then we will look at doing a migration. So think about that for a second. Because of our position, our mandate that we will never make things worse, we always have an ultra cautious approach. We pay a price in terms of work. We are going to copy a 1 billion row table to a partition table. This is why we don't just, when people say, I'm using autonomous, we don't just like throw in auto partitioning by default, because that's going to work their system pretty hard. And that's obviously resource consumed. But the facility is there. Automatic indexing does work hard, but nowhere near to the level that potentially big tables might with automatic partitioning. But the facility is there. It's available today on your autonomous databases. You can activate automatic partitioning. The other next step along the journey is automatic materialized views. Same thing, we'll see queries, in particular things like aggregation style queries running against large tables. If those tables appear to be predominantly static in terms of their data, we might suggest, once again, a facility where we do materialized views with automatic query rewrite. The facility, I think, is actually already live now as well. Once again, turned off by default, but the facility is there for you. So yeah, it's a good question in the sense that when autonomous database first came out, people said, where's the autonomous part? Then we went autonomous indexing and people started, oh yeah, that makes sense. It's a little bit autonomous, but yeah, it's a journey. We now have the autonomous partitioning, the autonomous materialized views, and more things will continue to come. Once again, making it a much more fully and fleshed out autonomous offering. It's 9:57. Let's see. Oh, I got more Q&A from our customers. Okay, what are the advantages and disadvantages of running FS clone, and when should it be run? I have a simple answer to that. I don't know what FS clone is, so I can't help you with that one, but I'll do some research. And here we go. I'm late to the game regarding instance additions. If I understand correctly, this works great for PL SQL, but other DDL cannot be versioned. If I'm wrong, I'll continue to research it. My context is a desire to roll back an application release to the prior version without a point-in-time recovery. Okay, you're right and you're wrong. The utopia and the complete implementation of addition-based redefinition does support DDL as well. And it's not necessarily the fact that you version your DDL. The way addition-based redefinition hangs together in terms of philosophy is that physical objects are cross all editions, and therefore they represent all components of all editions. So if I have a table with columns C1 and C2 in version 1 of my application, and in version 2 of my application, it has columns C2, C3, and C4, and I got rid of column C1, then the table actually has columns 1, 2, 3, and 4. It has all the columns that could possibly be in all releases. Version 1 of the application has a view that sits on top of that table, which only exposes the columns that were relevant for that version of the application. Version 2 of the application has the columns only relevant in a view for that version of the application. The table effectively is the entire life cycle of the application. It has all columns that ever existed in the application, and they are filtered out by the use of views, special views called additioning views on top of that. And then your code only ever references the additioning views. It never references the base tables. We have these things called cross-addition or cross-version triggers then, which are responsible for making sure that the stuff that happens on version 2 of your application does enough to make sure that the data is still correct in version 1 and vice versa, until at some point you retire the old edition. So it is quite possible to have all the DDL and all the PL SQL, and in fact everything just about, except for things that cannot be additioned, There's a few things like, I think, context variables and etc. Some particular objects in the database, directories, I think, but they're generally not, they don't consume space. You can do the whole thing in edition-based redefinition. A classic example of that is our own e-business suite. And we're talking 25,000 database objects there, 25,000 plus in terms of tables, indexes, etc. They do their live patching with edition-based redefinition. So rest assured, at the insane levels of complexity that e-business suite is, they still use edition-based redefinition for online migration to do patches and version upgrades. So it can be done. For me, one of the things I like doing is I often think I don't have to go maybe to that level. For customers that use EBR, one of the things that I've done is we've sort of adopted this what I call happy compromise, which is from time to time you do DDL changes in terms of table definition, etc. But you do far more frequently code changes, because generally you find bugs or you have small enhancements to make. So what we used to do is we said, let's use EBR anytime we change triggers, views, PL SQL, etc. If we're doing significant DDL changes, then we sucked it up, we took a downtime, and we actually did the application upgrade without doing the EBR stuff. And that was just a compromise, because once you do get a thing of embracing the whole EBR methodology, then it can get a bit more complicated, because you do have to make sure you're maintaining data correctness across all editions in real time. So hopefully that helps answer that question. Well, it's 10:02, but we have one more question that's come in from our live audience, and I feel bad not to serve it. So this will be our last question, and we'll wrap it up. In my 20 years as a DBA, I've never increased the % free for the table storage parameters to resolve hot block weights. Is this really a practical solution? Are there any lessons learned from increasing % free to say something like 50 or 90% on an 8K block? Yes and no. That's always one of those great questions, isn't it? In my experience, I've effectively done the same, but not using % free, but I have done it in terms of deliberately spacing out rows to get them spread across blocks. When I say I haven't used % free would have been a perfectly adequate solution. That's why I say it's yes and no. A couple of things I've done in the past is, one is a lot of those systems that came out of the sort of 90s, which used things like designer tools, you would have these tables called reference codes or metadata, etc., where you would dump a lot of very commonly and very hotly accessed data into these sort of very simple key lookup tables. You'd have sort of a list of valid, a list of valid suburbs, a list of valid states, a list of valid genders, all jammed in these tables that get hit very, very aggressively all the time. To avoid contention there, generally what we would do is we would do things, I would use what we used to call a single table hash cluster. And in that way, you could actually use the cluster size to spread out the rows across multiple blocks. Similarly, the other one is what we call the Hacken factor. If you go search my YouTube channel for Hacken factor, you'll see that's a facility that was originally used for bitmap indexes, but you can use it for tables as well. Effectively, you set a cap on how many rows can sit in each individual block, therefore mimicking the same % free facility. The reason those techniques have probably diminished in terms of frequency over the years is actually due to changes in the way we implemented the buffer cache. Back in the day, when you accessed a chain along the buffer cache, we took a latch which was exclusive, because the only thing that really existed in those days was exclusive latches, which means I'm reading some rows from a block and you don't even get to until I finish and release that latch. Round about Oracle, please don't quote me on this, maybe Oracle 10, maybe 9, maybe 11, somewhere around that time frame, we introduced this concept of shared latches, which means the latch is now a slightly more complicated memory structure, but it means people could come in with their intent, saying, I'm not just after a block in memory, I'm after a block, and by the way, I only want to read it. And therefore, multiple people could now share the same latch and read the same set of blocks in memory. Because of that, it was predominantly latch contention that created the issue with hot blocks. By resolving the latch contention, the problem with hot blocks generally disappears. So in that respect, you probably won't see it as frequently now, but there were in the past some systems I worked on which the access levels were so extreme, generally due to do with bad code, that we actually spread rows out across blocks, just using different techniques, but ultimately the same as a larger percent free. Hope that answered that question. Normally at this time of the year on my last office hours, I would always have a bottle of champagne and I would pop the cork and I would toast us. I would toast us as a community. I do have a bottle of champagne, but I could not for the life of me get my hand around the cork. And so we've had to abandon that, unfortunately. So all I will say is thank you very much for your support this year. I've always loved doing this office hours session. I love the fact that you come along and give up your time so freely. For me, I get paid to do this. You obviously don't. So thank you very much. Please have a safe and healthy and festive season, however way you celebrate this time. I hope 2021 hasn't been too much of an arduous thing for you, and I hope 2022 will once again bring us a little bit closer together. For the early part, I imagine it'll be Zoom again, but until hopefully later in the year, we can get some face-to-face stuff. Even though there won't be office hours until next month, as always, you can hit me up on Twitter. Follow me on Twitter. I'll be posting regularly. I don't have much of a life besides tech. Happy to answer your questions. My DMs are always open. If you have any dramas, please reach out. I would love to help you out. That's my job. Thank you once again. Thank you for enjoying these office hours and have a great rest of 2021. Bye for now, everyone.